Namaste, good morning, welcome to you all. Again we came today here with a new topic from digital electronics, that is SR Flipflop characteristics table and excitation table. Already you know the truth table in the flip-flop and LHS. So, this is the new topic, flip-flop characteristics. So, I have made three partition. First is the truth table. What is truth table? What is characteristics table and what is excitation table? You will know very clearly today in this chapter. We have mentioned these three things. In truth table, input versus output, whatever the input is there, suppose if you will take the SR flip flop, in that you will see S and R is the inputs and the output is the next state, and it was written by Qn plus 1. Same in the characteristics table, what happened? Input versus the next state. These are the inputs. And this is the next state, that is Qn plus 1. So, these are the difference between table and characteristics table. And in excitation table, what is there? Present state. This is the present state, and the next state, this is the Qn plus 1 is the next state, and the input S and R. If you will make the excitation table of SR, then this is the input and this is the output. In this chapter, we will focus on the characteristics, and the next point, it is in the truth table, it shows how logic circuit output responds to the various combination of the input. Whatever be the combination of the inputs, on that it depends the next state. In characteristics, it defines the next state of the flip flop in the terms of flip flop input and current state. These are the inputs and this is the current state. So, the inputs are there, are the three inputs S, R and the current, previous, we can say the previous state, or we can say the present state also. On that the output is depend on the next state, that is the Qn plus 1. But in this, what is happening here, where the output is given, already the output will be given, this and this will be the given, and we have to deduct possible inputs. What will be the value of S and R? Already the output will be given, according to the output, what is our input? So, we have to mention that. So, this is the little different table. In this, output is already written, we have to write the input. So, this is known as the excitation table, and we have to see this all the tables in the flip flop, which we will study today. And what is the use of excitation table? I have written here the one, we can say the one flip flop to another flip flop converting, when we will convert SR flip flop to JK flip flop, or by SR flip flop to D flip flop, or SR to T flip flop, any other flip flop. While converting those flip flop, we need the excitation table. And the next also, there is the particular logic. If we have to design the particular logic, we have to make the excitation table. So, this is very important, and we will see today how this characteristics table will be and characteristics equation will be generated, and from the characteristics table we will generate the excitation table. So, today we will study SR flip flop characteristic and excitation table. Now, see the SR flip flop using the output. In last lecture, you have already studied the SR flip flop using clock. So, this is the AND gate, this is the NOR gate, and this is the flop flop, and this is our truth table of NOR using SR flip flop. Here you have seen that when S is equal to 0 and R is equal to 0, and that time the next state was Qn, that means Q hold position. When it was 0 and 1, that is 0. When it was 1 and 0, the 1, that is the set state, and 1 1, that was the infinite. By the help of this table, we will see here. See, this is the characteristics table. In this, there is the inputs and outputs. In input, there is the S and R, and this is the present state, this Qn, and what will be the next state. So suppose the two, firstly S will be 0 and R will be 0, and assume Qn will be 0, then what will be the next state? So we already know when S is equal to 0, R is equal to 0, by the help of this table, we have already known it will be in the whole state. So whatever was the past, 0 was the initially, so the 0 is here. Again, when S is equal to 0, R is equal to 0, and the last state, but the present state was, here we have considered 1, initially we have considered 0, by now the 1, so we will put here 1, and what will be the next state? In truth table, if you will see the S is equal to 0 and Q is equal to 0, then it was the whole, so whole is our 1. So we can say this is as a whole state, because what was the initially on the Qn, that was our the next state. Now see the next, if S is equal to 0, R is equal to 1, if again I am making two lines for 0 and 1 and 0 and 1, suppose one time it will be 0 and the next time it will be the 1, what will happen? So when this will be the 0 and this is equal to 1, and we will suppose this is the 0, on that time by the help of truth table, this S is equal to 0 and 1, we got the 0. So this will be the 0. Already I have studied in the clock flip-flop. So finally that was the truth table. From that truth table, this characteristics table is going to be developed. Again, this is S is equal to 0, R is equal to 1, and suppose the present state is 1. What is the happening? 0. And this condition we will say that the reset condition. Now the another, suppose S is equal to 1, here also the two value we will take here. First time 1 0 1 0, here also assuming 0, and the next time 1. If the input is 1 and 0, on that time this was the set condition, that is the 1, and when again the input is 0 1 0, then the 1, and this condition is known as the set condition. Are you understanding? Okay, if there will be any query, just ask at the same time, so that I can solve your problem. If now S is equal to 1, R is equal to also 1, condition for 0 and 1, and we will see that this is the invalid condition. That means we don't know what is there. So we should write here invalid, and we will mark by cross X, but don't care. So this is the characteristics table of SR flip-flop. Now we will see the characteristic equation. So for characteristic equation, we know easily K-map, so we will develop the K-map. See here, there is the 8 inputs, so we will make 8 cells, 3 inputs, there is the 3 inputs already. So 8 cells, you can make the K-map like this, rectangle, or by the horizontal or the vertical. I have made like this. So our inputs are S, R and Qn. These are our inputs. So firstly we will draw the box. This is 0, this is 1, and this 0 is known as the S complement in the sub form, and this is the S. And here if this is 0 0, then this is the R complement and the Qn complement. This is 0 1, this will be R and R complement Qn. This is 1 1, because we are applying here gray code. So don't be confused. This is why there is not 1 0. This is not a binary. We are applying the gray code. So in gray, firstly this is 0 0 0 1 1 1, then 1 0, and this is known as the RQN, and this will be the RQN complement. According to that, the name of this cell is equal to M0, small m0, small m2, small m3, small m2. This will be the small m4, m5, m7 and m6. How this came? You know very well, because for this box you will see from this side, this will be the 1, from upper one, this is the 1, and the 1, 1, 1 in the middle, that is the 7, that's why this is the 7. Okay. I think you know very well. Now we will put the value, this value in this. Where is the 1? So see here, this 1 is in the 0, 0, 1. So the 1 number, 0, 0, 1. So here is the 1. Now next, 4 number. So here is the 1. 5 number, it is the 1. And in 6 and 7, you will see here, this is the 1, 1, 0, 4 and 2 is 6 and 7. This is the don't care condition. And we already marked with the X marks. Now you have to make the loop. So the bigger one, if you will see, the whole condition is applying here. We know that we can make the loop by 2 in the 2 raised to n form. So this is the 2 raised to 2, 4. So we can easily make this should be in the horizontal. There should not be any gap. If the don't care is important, you want to take, then take it. So this is the loop number 1. And this will be the second loop, so we should write this loop number 2. So what will be the output of Qn plus 1 output, that is the next step, is equal to, from the first loop we will see S is the common and nothing, so S, we should write S plus, and from this loop number 2 we will see these are not common, from upper one, that is the R complement and Qn, and this is our final equation. So if anybody will ask what is the characteristics equation of SR flip-flop, so we can say the Qn plus 1 is equal to S plus R complement Qn. So this is our characteristic table, and we have generated the characteristic equation. See this excitation table, what is here? There will be the 4 options, where I have written Qn, that is the previous state, and Qn plus 1, that is the next state, and S and R. We have told you whatever was the output, according to the output, what will be the input. So the maximum output will be 0, 0, 0, 1, 1, 0 and 1, 1. According to this, what will be the value of S and R inputs? So we have to decide from this characteristics table. So see here, for this one, for this input Qn and Qn plus 1, here is the Qn, here is the Qn and here is the Qn plus 1. See here, where there is 0, 0. So we will see here, this is the 0 and here is 1 is 0. Again we will see here is the 0 and 0. At 2 place we are seeing that 0 and 0. Qn is 0 here, Qn n plus 1 is also 0 here. These two are the 0 here for this one. On that time, corresponding to this value, what is the value of S and R? So here the value of S is 0, here also is 0, and here the value of R is 0, and this is the 1. So we can write, while the Qn and Qn plus 1 is 0, 0, on that time S is equal to 0, 0, that means 0. That means this is the 0. And when R is 0 to 1, this is toggling. So we should write don't care. It may be 0 or it may be 1. Now for this 0 and 1, see in this table where there is the 0 and 1, if you will see, then here is 0, Qn is 0, here is the Qn plus 1 is 1. Again you will see no one is there, only this much. So corresponding to this, if you will see, there is 1 and here is the 0. So we should write here 1 and 0. It is very simple. Now the third one, if you will see 1 and 0, where will be the 1 and 0? So, we will see 1, where is the 1? Here is 1. Are you getting? Here is 1, here is 0, and the next one, no one is there. So, while this is 1 and 0, on that time here this is 0 and 1, 0 and 1. So, S is equal to 0 and R is equal to 1. Now, the last one 1 1. So, find out in this table, here is 1, I will mark by the black ones here, here is 1 and Qn plus 1 is also 1, and next again here. On that time you will see what is the value here, and here is the 1 1. S is 0 1, that means changing, so it will be the marks by cross, and R is same 0 0. So, this will be mark will be this and this will be 0. So, this is our final excitation table of SR flip-flop. We have developed this from the characteristic table. So, now I think you get very well what is the difference between truth table, what is characteristics table, and what is exciting table. If there is any equation given and we will design for that equation particular, then on that time also this excitation table is very important. Okay, so any query you all the student and my dear friends who have not understand about the SR flip flop, so you should please refer our last lecture, already I have taught, so you should see that, and after that you should see. So, thank you, all the best in the future. Please like and subscribe, don't forget to like and subscribe. So, please like it, share, have a good day, enjoy your day. Thanks a lot. Namaste.